Karan, welcome back to the podcast. It's a pleasure to be able to speak to you again so quickly. I think we were just saying off air, it's been about 3 months since your first appearance on the podcast.
That's right. Yeah. Thank you so much for having me. It was a great conversation the first time. So I'm excited for our chat today.
Yeah, no, absolutely. And I know our listeners are super excited for this one as well. I guess because of your recent appearance, we can ignore the official introductions and kind of dive into today ultimately, which I guess I was saying off air, we initially planned in to talk about the gut brain axis, but I would also love to pick your brain around histamine.
Mhm.
And my understanding is, there's to some degree quite an intimate connection between these two things anyway, with histamine quite being a sort of neurostimulatory neurotransmitter ultimately.
Mhm.
So, with that in mind, I guess I'll throw the ball into your court in regards to where do we feel is a good place to start? Maybe starting with the concept of introducing histamine and going from there.
Yeah, we can, and of course we can, discuss how the gut and brain are connected to give people an understanding of how intimate this connection is between the gut and the brain. What role does things like histamine and of course other stimulatory, inflammatory factors play, and then ultimately what is driving cognitive degeneration, right? So that's the big issue here with aging and age-related disorders and slowing down of the mind, if you will. And then ultimately also mood disorders, which are incredibly prevalent from every age group that we see now, and really, ill-managed when you look at how the healthcare industry deals with anxiety, depression, and all that, right? So what are the root causes of these things? So I think there's a lot to unpack, but I think if it makes sense, let's start with how the gut and the brain are connected.
Okay.
Since that's kind of a key component to a lot of this. It's important for people to note that the gut is basically covered with something called the enteric nervous system, right? So this is the neurological system that covers basically every square inch of the digestive tract from the mouth all the way down to the bottom. And the enteric nervous system is the second most number of nerve endings next to the brain, even more than our spinal cord itself, which was always thought to be the most complex part of the central nervous system outside of the brain. But as it turns out, the enteric nervous system is actually closer to the brain than the central spinal cord is. And the enteric nervous system is, of course, as I mentioned, connected to the digestive tract, which means that all the microbes that live in the digestive tract, which is tens of trillions of microbes, have access to this enteric nervous system. And this enteric nervous system is directly connected to the brain through a bidirectional pathway called the vagus nerve, right? So there's a deep neurological connection between the brain and the gut. The brain can send signals down directly to the gut, and the gut can send signals directly up to the brain through this bidirectional highway. Beyond that, there's a number of other things. One is through the immunological pathways, right? So immune responses in the gut have a direct impact on the brain, even pretty deep recesses in the brain, areas like the hippocampus and amygdala and so on. So we see that in the research. And of course, we come to find out a few years ago that the brain has its own lymphatic system, right? So we know that immunological components that are generated often in the gut and or adjacent to the gut can make their way into the brain. Histamine is part of that story as well. And then there is the standard circulatory system, right? So nutrients and postbiotics that are absorbed from the gut, postbiotics being compounds that are made specifically by the microbiome, things like hormones and peptides and so on, get absorbed into the circulatory system and through the circulatory system into the brain as well. So there's a number of ways in which the gut directly influences the brain. And of course, the brain has a direct influence on the gut. And we are caught kind of in the middle of this continuous gut-brain conversation. And ultimately, as it turns out, the thing that becomes the most toxigenic effector of the brain is the gut. So over time, as you look at brain-related dysfunction, so whether it's cognitive decline or conditions as severe as Alzheimer's or Parkinson's, other central nervous system disorders, or even the things that we deal with on a more prevalent basis like anxiety, depression, and so on, all of those are driven by a dysfunctional gut. The studies are pretty clear on the root causes of all of those things. So it really, we can't overstate the importance of understanding the gut-brain connection, and what compounds like histamine and brain-derived neurotropic factor and inflammatory cytokines derived in the gut, how all those affect the brain, right? So that kind of gives you an overview of what the brain and the gut, how they're intimately connected.
Yeah, absolutely. Perfect. So with that in mind, I guess you've mentioned some of these, mediators, compounds that are what are communicating between the gut and the brain, and how histamine has a role to play, especially within the immune pathway from the gut to the brain.
Mm-hmm.
So can we maybe expand on that specific pathway and how sort of histamine, the role that it plays within this?
Yeah, histamine is interesting because it can be a compound that's designed to excite the neurological system, right? It's a way of, there's a couple different uses of histamine that are quite relevant here. Number one, obviously your immune cells that produce the histamine compound, right, are trying to elicit an inflammatory response to protect the host. It'll do it in response to overreacting to an antigen, right? So an allergen that you might be sensitive to. So your IgE type of producing cells, your eosinophils, basophils, they're going to produce these types of compounds to elicit inflammatory responses, which are supposed to protect the host, but more often than not causes the host more dysfunction and problems, right? So, but that same histamine can have an amplification response in the neurological system. And a lot of these types of signaling molecules that are used by the immune system have that type of amplification response. The reason for it is it's trying to excite your central nervous system to a certain degree, because in part what you're supposed to do in response to the presence of histamine is move away from whatever is triggering the histamine response, right? So let's say take your ancestral self and you're wandering through the wilderness and foraging and so on, and you come across a tree and you sit next to the tree and something on the bark of that tree triggers a hypersensitivity response, right? It would not serve you well to continue to sit and lean on that tree and try to scratch yourself and figure out what's going on, right? You're supposed to get amplified. Your neurological system's supposed to get turned on for you to be able to get up and move away from that triggering offending compound, whatever it may be. So there is this direct component of triggering the flight or fight, triggering neurological activation by these types of compounds, because they're supposed to try to protect you. It's no different than if you put your hand on a hot burning stove. The nerve signals from the hand are supposed to trigger your muscular reaction to move away from it, right? It's an automatic response. So imagine if we have a dysfunctional immune system and dysfunctional microbiome, and we can talk about how a dysfunctional microbiome increases histamine expression, but a dysfunctional immune system microbiome with constant release of histamine, we're constantly in this excited, amplified state. And it becomes harder and harder to go into the parasympathetic type of state where you're resting, you're rebuilding, and so on, right? And histamine, of course, triggers inflammation, which means damage to tissue. So we're constantly in the state where we're amped up and we're causing tissue damage, which is really not a good place to be all the time. That's supposed to be a response to a trigger to protect the host, but if that's a chronic state, that becomes a real problem quickly.
Yeah. So, you've mentioned how certain immune cells are producing or releasing histamine into the system. So we've got that sort of allergen exposure type route. But obviously, I've seen some of the research discussing mast cells being activated by mold and mycotoxins, by Borrelia. There's an interesting paper talking about the relationship between the thyroid and mast cells. But what you mentioned there around the microbiome is obviously going to be a really interesting area for our listeners to hear you kind of expand on. So
Yeah.
what's the connection with, I guess, the kind of gut and gut health with this?
Yeah, so in fact, some of your commensal organisms will produce histamine directly as a postbiotic. So your microbes that live in your gut will actually produce histamine as well. Often it's a way of signaling to the immune system that there is a chronic infection or there's some sort of dysfunction in the ecosystem, right? So if you have latent viruses, for example, that inhabit your system, long-term viruses like cytomegalovirus, Epstein-Barr, and so on, those types that know how to hang around for a long period of time without being detected by the immune system, those can trigger microbes in the region to produce histamine. They produce histamine, they produce things like taurine and other compounds to try to excite and attract the immune system to that site of action, right? So in some ways, histamine overexpression is also independent of the immune system creating it. It's also the microbes, but it's doing so because it's indicating a chronic infection, right? So that's another driver of histamine release. Now, that signals two problems, right? So one is that there is some sort of dysbiosis going on, meaning you've got an imbalance of microbes within the system. You might have some sort of latent infectious organism sitting there. So you've got that is triggering other organisms to produce constant levels of histamine. Or you could also have pathogens or opportunistic pathogens that will produce histamine as a way of distracting the immune system from its presence, right? So certain opportunistic organisms do well under inflammatory conditions, and they try to elicit those inflammatory conditions by producing compounds that either A, will directly activate the innate part of the immune system, right, to upregulate inflammation, or B, produce molecular mimics to parts of your own cells and so on to activate the immune system and misdirect the immune system to a different target, right? So a lot of it comes down to that ecological problem of dysbiosis. And these are systems in place to protect the host, but they pretty quickly go awry when you've got an imbalance of microbial activity in the system, right? So, and it's also important to note at this point, so your audience understands that the way we function, the way our immune system functions, is our immune system is one of the only systems in the body that is constantly adapting to the environment, right? The whole idea of the immune system is it's the only immune system within ourselves that is directly designed to protect the host, which is us, right? However, the immune system functions differently depending on where you are, right? If you live in Mexico City, your immune system functions differently and has different tolerances than if you live closer to the Arctic Circle, right? Very different ecosystems, environments, different pathogens, different allergens, different food components, environmental components, and all that. So your immune system has to adapt to its ecosystem. And it's one of those systems that's constantly adapting because weather changes, right? Season changes, completely changes the antigens around you, right? That trigger immune responses. So your immune system is supposed to continuously adapt. The way the immune system adapts is it uses the microbiome as a translational tool. The microbiome provides the immune system signals on what is going on in the environment. The immune system on its own does not know how to read the environment that you're in and adapt to it. In particular, the idea of what to attack and what not to attack, right? Because as important as it is for the immune system to understand what is a pathogen and attack it and protect you from it, it's equally or arguably even more important for the immune system to not attack all of the myriad of things it encounters that it shouldn't be activated, right? So that tolerance is dictated in large part by the microbiome.
Okay, amazing. So we've got endogenous production in immune cells. We've got microbes producing histamine as a kind of defense mechanism to help them survive. One thing that I would love to kind of touch on is I guess moving into the idea of what is histamine intolerance then in regards to an imbalance between this build-up and degradation. But before we do, are there any other mechanisms that we could highlight in regards to, I guess, basically SIBO and histamine, because that's obviously quite a big conversation that people ask us around. There's a lot of information out there, but not much from an evidence-based perspective. So what's your understanding and experience with sort of SIBO and histamine issues?
Yeah, so histamine response is a default response in many cases when the immune system is ill-equipped to protect the host, right? So one example of that is when you have low levels of secretory IgA, right? The way your immune system compromises is it increases the amount of IgE. Right. So when you don't have the B cells adequate enough to produce the IgA, and IgA should be constantly produced and changed based on what the microbiome environment looks like in the gut, right? These B cells are sampling what's happening in the ecosystem, and then building tolerance to the microbes that are living in your gut, but then building intolerance and direction towards new microbes that might come in. So the IgA profile keeps changing. However, if you don't have enough of those cells, of the B cells activated to produce enough IgA, what tends to happen is you tend to get more activation of basophils, eosinophils, and all that to produce more IgE and histamine and allergic type of responses, right? That's kind of where your body goes as a default response to everything that's entering into the system. So when you look at somebody with SIBO, yes, there's the overgrowth part of it, right? So there's that small intestinal overgrowth. That's a signal of dysbiosis. But ultimately, what SIBO people have that really create that whole myriad of issues that they experience is they have severe leaky gut in their small bowel, right? Because there's a taxa shift of organisms. You get more gram-negative bacteria over time. You've got really high levels of bacteria that shouldn't be there. You're releasing more LPS into the environment. And so what tends to happen is you tend to get a depression of proper immune activation because you have the wrong bacteria, you have leaky gut, so you've got constant inflammation, and your secretory IgA levels will start to drop. The B cells that are supposed to be activated by the microbiome, by a healthy, diverse microbiome, actually don't get activated. And so your body responds by recruiting more inflammatory cells like basophils, eosinophils, with IgE, histamine type of response to that region, right? And then now, because you're losing oral tolerance, right? Because you need that B cell that's making IgA to help you develop oral tolerance to the organisms that live in your system. And you also need that healthy diversity and balance of organisms to upregulate the Treg system, which regulates all of the immune responses, right? You're getting a depression of both of those. So then the inflammatory histamine type of responses continue to escalate. And they continue to be triggered by these new organisms that are living in your small intestine that typically shouldn't be there, right? So it's a vicious cycle. So you're feeling it through bloating and the inflammatory responses and the intolerance to food and all that. You feel that, right? But what's actually also happening is you're getting a continuous perpetuation of this dysfunctional immune response because the key ones, the IgA, the Treg responses are being suppressed. So it's a cycle, right? It just gets worse and worse. That dysbiosis will increase over time. Leakiness in the gut will increase. More inflammation, less IgA, less Tregs, and that means more IgE, more histamine, and so on.
Amazing. Okay, there's a lot there.
There's a lot there, and the problem is then you develop this issue of what we're labeling as histamine intolerance. What that really means is that lots of things you eat, rather than triggering a tolerance response, is triggering an immune response, and that immune response happens to be a histamine-directed response because that's the part of the immune system that's now functioning to try to protect you, right? And you don't have the Treg system that's going, hey, we don't need to respond to this, turn it down, right? So now we've got this constant inflammatory response to everything that you're being exposed to. And of course, some things will trigger a higher response than others, just on the nature of the antigen. But that intolerance, it's not necessarily an intolerance to histamine itself, right? It's not that somehow you've become allergic to histamine, or histamine itself is the sensitivity. Histamine is the communication tool that the dysfunctional immune system is using to amplify response.
Okay. And does this start to explain why studies where they've taken participants with IBS, which obviously is a diagnosis of exclusion, as we all know, there's lots of research showing that there's this kind of migration of mast cells into the laminopropria or the gut lining, so it's kind of almost a double whammy, it sounds like.
That's exactly right, because what they show is that as you lose diversity, the right type of diversity in the small bowel, even, or in the large bowel, it's equivalent for both. And as you start to get a taxa shift of the wrong type of bacteria, so in a healthy small bowel, for example, you should have more gram-positive bacteria than gram-negative, right? Gram-negative bacteria tend to be at a relatively low level. But if you start getting this dysbiosis and increase in those microbes, you start getting lower activation of plasma cells and B cells to produce IgA. And because of that, it recruits in more mast cells and eosinophils and all that to try to replace the IgA B cell protection that you normally have with this alternative, right? So it's a default way for your body to try to protect you. The idea probably from an evolutionary standpoint is that, hey, you need some protection there, right? Because that's the biggest source of incoming foreign material, right? It's going through your stomach, and then the next spot is going through your small intestine. So you need immunological activity in that area. If you don't have the normal immunological activity, we're going to pull in whatever we can, and it happens to be mast cells and so on. So it's all driven by this imbalance. But I think the good news here is that it doesn't solidify that this is now how your body works, right? There is a way of balancing it out and bringing back the IgA, bringing back the active, the right plasma cells, bringing back the Treg system, and then diminishing the mast cells. So that I think is the most promising aspect of all of this.
Yeah, absolutely. And I guess maybe that's a great way to conclude the conversation. But if we back up a little bit before we start talking about some of how we can rebalance, modify what you've been discussing, would it be okay, I guess, just to touch on sort of DAO and the role that plays within the gut lining and how that can be compromised, which I guess, again, is another element to this whole conversation. Mm-hmm. And then I guess how several things that you've been bringing up there then connect back to the gut-brain axis and cognitive function.
Right. Yeah. Well, so, let's start with the gut-brain axis and cognitive function, which is it's such an interesting area. It's really, I think, underappreciated by most people, especially when you look at people who are professionals dealing in psychiatric and mood disorders and all that, right? And it's evolving, it's coming around. I think the International Association of Psychiatric Physicians or something like that, I can't remember what the acronym is, but in the last 3-4 years, they've had more and more keynote talks around the gut-brain axis. So I think it's evolving, but obviously it's not quite there yet, because gut-brain therapeutics are not the standard just yet, right? So what seems to be really clear, and a lot of this is from the research out of the APC in Cork, Ireland, which is one of the world's most renowned areas of research for gut-brain axis stuff. What seems to be clear is there are inflammatory pathologies in the gut that occur in the lining, in the mucosa, that translate into the lamina propria, and then, of course, into circulation or through the enteric nervous system, that then trigger inflammatory responses in the brain as well, right? And it does so by activating the HPA axis. And one of the big problems there is you start to activate microglial cells in the brain. And microglial cells are the equivalent of macrophages in the rest of the body, but microglial cells kind of focus on the brain, but they have an interesting ability to upregulate something called TNF alpha, which is a inflammatory cytokine, inflammatory compound. And that inflammatory compound will trigger the HPA axis. And when it triggers the HPA axis, it causes the release of cortisol, it causes a release of epinephrine and all of these stress-related hormones, right? And what tends to happen is because those are being released now in the brain, it actually creates an atmosphere for opportunistic organisms to start to rear their ugly head, right? So it's a cycle. If your audience can think about it this way, and the cycle can be triggered on both ends. It can be triggered in the gut, or it can be triggered through external stressors. So let's talk about the gut side of it first. So let's say you have dysbiosis and leaky gut, or you've got inflammatory conditions going on in the gut. This is evidenced by the fact that a number of classes of antibiotics, one of their side effects is like sudden onset of panic and anxiety disorders, right? Because they're going in, they're disrupting the microbiome quite significantly. This is causing inflammation in the lining of the gut. That inflammation in the lining of the gut gets translated through the mucosal system and through the circulatory system into the brain. And that activates the microglial cells in the brain. When the microglial cells in the brain get activated, it triggers through the HPA axis, the hypothalamic adrenal pituitary axis, to release the stress hormones, right? And stress hormones, if you think about them, it really is about triggering our flight or fight response, right? So the body, every time it encounters something that's not good for the host, whether it's damage to the gut, it's trying to get you to pay attention to what your environment is like, right? And that's the whole purpose of the flight or fight. It's like, do I leave from this area? Do I somehow fight and defend myself? But if we're having that type of inflammatory response and damage in the gut all the time, your body is designed to trigger a flight or fight response to get you to get away from whatever's hurting your system, right? And so the unfortunate nature of it is that it's just dysbiosis. It's things we're chronically doing. So we're chronically activating this fight or fight response in the brain. And part of the problem with that is there are opportunistic organisms in your system that have evolved to look for these stress hormone signals as a way of them activating their virulence factors, right? So they're opportunistic in that they're waiting for the right opportunity because they're not strong enough pathogens to be a direct pathogen, one that can come in and right away start, hurting the host. They sit around and wait for the right opportunity when the host system is depressed. What they've learned over time is that when stress hormone levels are high, the immune system is depressed, so that's a good time for them to rear their ugly head, right? So you've got gut inflammation driving brain inflammation, which then releases stress hormones. The release of stress hormones causes opportunistic organisms in the gut to activate themselves and create more dysbiosis. And many of those opportunistic organisms, part of the way they function to try to maintain the status quo that helps them is they have the capability of producing neurotransmitters and toxins that further create the release of more stress hormones, right? So it's this continuous cycle where your gut becomes more and more dysbiotic because your brain's inflammatory pathways are activated. And because your gut is getting more and more dysbiotic and inflamed, your brain is getting more and more dysbiotic and inflamed, right? Releasing more and more stress hormones. So it's this continuous cycle that goes on between the brain and the gut. Now, there can be the other direction as well, where it starts in the brain. External stressors, and there's a good number of studies coming out on this, where they show that external stressors, so whether it's traffic as you're trying to commute to work, or a workmate or somebody you're living with is causing you stress, whatever it may be in your life, right? And so that external stressor gives you a perception of stress, and that stress response that you're having to that external stressor increases inflammatory signaling in the brain. That inflammatory signaling in the brain, again, is enough to start triggering dysbiosis in the gut. In fact, a recent study in 2020 shows that even small bouts of external stress over time will actually create significant dysbiosis, and it does it through the gut, right? So that external stressor will create a dysbiotic condition in the gut. Then the dysbiotic condition in the gut will provoke more stress through the inflammatory pathways. So it comes in both ways, right? So when I talk to people about managing mood and managing stress and so on, it becomes equally important to deal with the gut dysbiosis as it is to deal with managing external stressors as well, because the cycle can occur at both ends and in fact perpetuate from both ends.
Yeah, I think that's a great sort of insight into why, we emphasize a holistic approach to this. We often want a 2-3-pronged approach to this. And I know there's an interesting study in people in the military showing that kind of psychological and physical stress of their training contributes to intestinal hyperpermeability. So there's some really kind of robust evidence there now, which is great. Thinking back to, when I used to read people like Peter Check's book, I think in like the mid-90s, when he was talking about leaky gut and being called all sorts for the concept.
Yeah.
Yeah.
Right.
So with that in mind, Kiran, obviously that's probably a nice way into therapeutics, unless there's anything else that you want to just finish off sort of expanding on.
Yeah. I think at the end of the day, what we're seeing, and we're involved in a lot of studies on this whole idea of stress cycling and inflammatory cycling between the gut and the brain. And what we're seeing is that it has an impact on a number of functions. Obviously, one of the most easiest things to understand is if you have continuous stress cycling and inflammatory cycling, it's going to disrupt your sleep, right? Because sleep can only occur when your brain is not in that sympathetic state, right? When your neurological system is not activated in that sympathetic state. And in fact, it has to go very much the opposite, go into the parasympathetic, activate things like GABA and brain-derived neurotropic factor and so on. So sleep gets disrupted. Now, when sleep gets disrupted and you don't go through all of the proper sleep cycles and you don't sleep for long enough, that drives even more dysbiosis, because one of the things that occurs in the gut is, and the gut is a diurnal system where it has a 24-hour clock, right? 12-hour cycling. So during the rest phase at night, there are certain organisms that proliferate, and part of what they do is a lot of housekeeping function. They stimulate things like mitophagy and autophagy, right? So they stimulate the process of cleaning up dead mitochondria, damaged mitochondria and cells. They also, stir up the process of cleaning up cellular debris and damaged DNA and all of this debris that occurs from all of the metabolic functions that go on. So that nighttime activation of these housekeeping organisms is really critical. And you start to get less and less and less of those if your sleep is disrupted significantly. So now, not only are you stressed, are you inflamed, but you can't clean the system, right? So you get over time, an accumulation of dysfunctional cellular debris and so on. There's a couple of different issues with that. There are a number of cancers associated with poor autophagy, right? Not removing damaged DNA, proteins, and so on. But then those also end up becoming immunological targets. So if you are continuously inflamed, your immune system may mistakenly see those as foreign and start attacking those at some point, thereby setting you up for autoimmune conditions, because now your immune system's geared towards attacking your own tissue, right? And then going even further than that, it screws up your metabolic process. Obviously, it creates more inflammation in the brain, so more risk for things like migraines and vision issues, and I mean it goes on and on. So it's really important to note that this cycling, this inflammatory stress response cycling, is really, to me, one of the key things that's at the root cause of so many chronic issues that we see in the modern world, right? This is not something that's really quite seen in the hunter-gatherer tribes in Tanzania and Papua New Guinea. We work with a researcher named Jens Walter, who's done a lot of work with those Papua New Guinea tribes, for example. You just don't see that kind of problem with them, right? This is an effect of the modern world. And so it's so important to talk about this, and so important to give people some sort of solution to try to arrest the cycle.
Yeah, I mean, that's amazing. Like, I was not aware of things like the IgA, IgE connection, for example, and how specific microbes have a role to play within autophagy. I think it obviously sounds so similar to the glymphatic system that you mentioned earlier, and kind of the brain housekeeping that happens in deep sleep. And we have the same within the microbiome, which is fascinating.
Yeah.
So with all that in mind, is there anything else that you want to touch on before we think about therapeutics and how we can start to shift some of this back?
I think at the end of the day, we are all in a place, having gone through everything we've all gone through in the last 18, 19 months, where, we are actually more in need of arresting that cycle now than, ever before, right? Arguably, at least, in part because of the role that things like over-sterilization plays in dysbiosis, right? So for a long time, most of us were hyper cleaning everything that we came in contact with in the beginning of the pandemic. And we know from studies that kind of over-sterilization, all that has an impact on your microbiome. On top of that, you add in the external stressors of uncertainty from economic, health, political, all of those points. We have endless external stressors that create and trigger all of this. So I think this is the absolute right time to be talking about this and talking about what can people do about it, because I think it's needed more now than any time in the recent past.
Yeah, absolutely. I imagine we've got quite a long list of tools within our toolkit that we can start thinking about here ultimately.
Yeah, absolutely. And I think, as you mentioned, it really requires a holistic approach, right? Because it's not any one magic bullet that's going to do it. Because if you deal with one trigger or one complication, let's say the gut, but you're also not doing mindfulness work and stress management and all that, you're going to continuously trigger that same cycle from your external stressors, right? The vice versa is true as well. If you just deal with managing external stressors and your response to those, if you're not fixing the gut's going to continue to perpetuate the problem. So I think we have to talk about tactics that deal with both. And I think ultimately what I always like to talk to people about are things that are the simplest to incorporate, right? Because hey, I would love to be able to get into transcendental meditation and become a yogi-like person, but it's not going to happen, right? It's not part of my daily routine or personality. And it's just, and I'm going to have external stressors, just the nature of life and jobs and work and family, and I also don't have as much time to put into all of these really awesome practices. So I have to really focus in on the simplest things that I can incorporate, right? And things that will make translate to an effect. And so if I try to empathize with other people's positions and I look at myself and I go, okay, what can I incorporate in my life that helps with both of those approaches, right? So that's kind of the way I'm looking at it. And I do want to point out that we're releasing a new strain. It's called Bifidolongum 1714. What's exciting about this strain is it was discovered at the APC. As I mentioned, that's in Cork, Ireland, one of the world's renowned gut-brain research institutes. And what they found was that this strain was really abundant in individuals that had very good cognitive balance, right? So people that dealt with stress really well. And there's many ways of doing this. You could take individuals, hundreds upon hundreds of individuals, and you can put them through stressors, right? You can put them through video game simulations and all that create stress in people. And then you measure stress response and brainwave function, and you look for people that have a really great ability to deal and mitigate stress response, right? Both cognitively and then biologically as well, as can be measured through hormones and inflammatory signaling. And so what they did was they started looking at individuals that dealt really well with stress and looking at changes or differences in their microbiome between people that did have very poor stress response. And what they found was a lot of these people that had amazing stress responses and tolerance had an organism living within their system, which is thought to be a keystone species, but it's called Bifidolongum. So Bifidobacteria longum. But there's a unique aspect of this longum that is not found in most of the longums. And it has this thing called an exopolysaccharide, right? So it's a polysaccharide covering. It's like a carbohydrate type of covering around the bacteria. This is not a common thing among bifidobacteria. But it turns out that polysaccharide covering has all of these little tentacles and all that create a triggering effect in the anti-inflammatory pathways, right? So this strain has a very unique capability of bringing down the inflammatory pathways, upregulating the Treg type of pathways in the gut that directly impact inflammation in the brain, right? So what they found is that part of how these people tolerate stressors better is that their gut is more robust in handling that continuous cycle of inflammation and stress hormone signaling, and that this strain played a critical role. So then, of course, the next idea is, can we take this strain and put it in people that do have stress issues, and will it change? And sure enough, once you deliver this strain to people who don't have it and who have poor stress response, their stress tolerance increases quite dramatically. Their cortisol release in the presence of stress decreases dramatically. And one of the most exciting aspects of it for me is we saw a very significant shift in brainwave function, right? Most of these people went from being a delta wave dominant, right, where they're kind of amped up and kind of, frantic in many ways, to a theta wave dominant, which the theta wave is the flow state, right? Which is what we all want to get to, where you're really tuned in, your brain is working at high level, but you're very calm and relaxed, right? So we all want to get into that flow state, and there's all of these mechanisms to try to do it externally. But as it turns out, when you take this organism, it puts its host in the flow state, which is just mind-boggling when you think about it. Then, of course, as I mentioned earlier, stress is related to sleep quite intimately. Of course, it also demonstrated that your time to get to sleep reduced dramatically, so you fell asleep faster. The quality of sleep improved dramatically based on REM analysis. And then that theta brainwave stayed throughout most of the sleep cycle, which then has an anti-inflammatory repairing effect on the body, all from this one organism in the gut, right? So what's exciting about that is you can really do a leap forward in dealing with these types of issues by just incorporating an organism like that into your system, right? So that's one big step that you can do. The second big step that's going to be really important is arresting leakiness in the gut, right? Because continuous influx of lipopolysaccharide, which is an endotoxin made by gram-negative bacteria in a dysbiotic gut, when that leaks through, LPS will actually migrate up the enteric nervous system through the vagus nerve, enter into the brain, and in the brain, it actually lodges itself in dopamine and serotonin receptors. So even if you're making adequate dopamine and serotonin, it's preventing the binding of it in the brain. So you're not getting the happy hormone and the satisfactory effects. So then what tends to happen is you're trying to trigger more dopamine release by doing things that you normally know releases dopamine, like eating food and doing things that excite you and so on. And that starts to lead to addictive behaviors, right? Because people are trying to release more and more and more dopamine, and people will find more extreme ways to do that, right? And then maybe going to recreational drugs or getting addicted to porn, whatever it may be, right? You get obsessed about it, you try to trigger more and more of it. So stopping the leakiness in the gut, and of course the spore-based probiotics do that better than anything else based on the research that we've published. And then of course, dealing with improving diversity within the microbiome. There's lots of simple things you can do with that, right? Number one is some intermittent fasting. Intermittent fasting can be really beneficial to increasing the diversity in the microbiome. A simple, 16-hour fast, mostly overnight. The 16-8 routine for me is a very easy one to keep up with. And that's something that I do constantly and have done probably for 4 years now. And then once in a while, I'll throw in a bit of a longer fast, especially if I've had a weekend of too much fun, right? And you need to really kind of give your body a bit of a reset. I'll do like a 24-hour fast or a day, and then go back to my normal 16-8. Getting out into the outside environment has a huge impact on the diversity of your microbiome, on arresting inflammatory signaling in your gut, and also helping with the leakiness of the gut. It's pretty clear when you get out into untouched environments And I'm not talking about necessarily walking down the street as getting outside. You need to go out into a natural environment. And I always recommend to people to be prescriptive about it, right? Because we all know going out in nature is a good thing. I think instinctively we know, but we don't prescribe it to ourselves to do that, right? So I try to prescribe it in my routine where I go, 30 minutes, 3 times a week. It's from this time to this time that I'm going out. I'm going for a hike or a walk nearby, or I'm just going out for a bike ride in the woods. I like mountain biking in the woods. And so I try to prescribe it for myself because it's that important, right? And talk about histamine response. When you can get more diversity and exposure to the outside environment, things like histamine, mast cell responses and all tend to come down, right? So we see that in allergy and asthma studies that are being done on kids, for example. And then managing the external stressors, right? There's so many ways to do that. One of my ways is, and I think we talked about this maybe off the air, was staying away from news cycles and news sources, right? Which is an absolutely easy thing to do, and it'll make a big difference, right? One of the things that started early on when the pandemic kicked off is, of course, a huge polarization of opinions on how to go about things, what's happening, and so on. And if you go online and you start engaging in those threads or even reading them, right, it can create so much stress in you. And there's no beneficial end to it, right? It's not like through this Facebook argument thread that someone's going to come to some amazing conclusion, and everyone's going to be on the same page. No, it just keeps perpetuating, gets worse and worse and worse. And so I've stayed away from all of those kind of things, right? I just don't look at posts like that. I don't follow those threads. I don't engage in any of stuff because it doesn't come, there's no fruitful end to it. And same thing with, driving in traffic. I used to get really frustrated when somebody kind of cuts me off, but I try to increase empathy and go, what, something's going on in their day where they're in a rush, whatever it is. It's not like they're trying to victimize me, right? They don't know me. It's not crossing in their brain. But often if you feel like, what the hell, they're doing this to me, you feel victimized and you get angry about it. I try to pass those things off and be a little bit better about dealing with those. And then I do simple meditation apps, 5-10 minutes before bed, 5-10 minutes when I wake up. That's about the most I can do, but I find them to be quite beneficial to kind of start changing brainwave and mood and start reducing some of the central nervous activation. So, and then lastly, diet, right? So depending on what's going on in your world, the more diverse your diet can be, the better off your microbiome is going to be, and the less inflammation, less leakiness in the gut you're going to have. So if you can increase the diversity in your diet, that's something that can be really quite powerful over time. And when you add all these things up, right, if you are taking the right probiotic for leaky gut, if you're taking this 17-14 strain for the stress cycling management, if you're going outside 2-3 times a week, if you're eating a more diverse diet, if you're doing a couple of things to manage external stressors, when you add all these things up, it's really a profound effect on your system, right? Any one of those things by themselves may give you some benefit, but it's really about the additive factor of these simple steps that really will have a profound effect.
Brilliant. And I guess, thinking just out loud that the Bifidobacterium longum strain that you're discussing it falls within this category of psychobiotics.
Mm-hmm. It does.
So organisms that are influencing our psyche ultimately.
Absolutely, it does. Yeah, and what's interesting to note is that because it's a human isolate, right? What you see when you're screening people for it is that it seems to be present in some people and then somehow eliminated or absent in other people, right? And one of the things we know from studying like the New Guinea tribes and all that, and this is hard to say in a modern population because our populations are so big, right? And the lineages are quite diverse. So it's hard to say the origin of these species and were they at some point present in most people, and now they're only present in 10%. But what you see in the Papua New Guinea tribes, because their networks and their villages and all much more close-knit still, that certain beneficial organisms are present in everybody, in all of them, right? And we're part of the work we're doing is trying to figure out what those organisms do, isolate them, and figure out how can we get them back into our system, because we, through our practices, through monetization, through use of antibiotics and all of the myriad of things that kill microbes in our system and negate diversity, we've lost some of these organisms almost permanently. And so there's another organism, there's a lactobacilli strain that we've identified in the New Guinea tribes that seem to be present in everybody in all of their tribes at a very high level, and absolutely extinct from modern humans who live in the developed world, right? And as it turns out, this organism seems to play so far a significant role in inflammatory pathology, which is, again, a big thing that we deal with in the modern world, but also in cognitive function. So not necessarily the stress cycling, but in alertness, awareness, memory, recall ability, all of those things, all of the things we're trying to use nootropics for. There are microbes within your system that are supposed to keep your brain in tip-top shape, right? And evolutionary, it makes sense. Obviously, those that have the right type of microbes and the right, balance will survive better. They're more, keen, they're more alert, they're more aware, they're smarter, they can figure out tools better, all of that stuff. So natural selection has driven that. But what we've done in the last several decades is we've eliminated a bunch of those types of microbes from our system because of practices. So part of our goal is like, okay, can we identify some of these ancestral bacteria that are clearly important for function that we've eliminated and get them back into our system, right? So kind of a rewilding of our microbiome. So yeah, and there's so many microbes in the system that are psychobiotics, right? That are natural psychobiotics, and we've really decimated them. And so it's no wonder that we have this increased crazy prevalence of psychological and cognitive issues.
Yeah, absolutely. And what you're saying there around these sort of keystone organisms that are found in everyone within the tribes, it kind of then aligns with some of the research talking about a core microbiome and then the more personalized element of it, which is really interesting.
That's right. And if you look at even just plain diversity among these tribes, these humans versus us, the modern industrial human, they have almost double the diversity that we do. They have almost twice as many species of organisms in their microbiome than we do, right? Which to me is crazy scary, because when you think about the fact that we've outsourced the vast majority of metabolic work that we need to do to be human, we've outsourced the vast majority of it to microbes, right? We don't have enough genetic elements in our cells and chromosomes to conduct even a fraction of all the metabolic functions that we need as humans, right? With some estimates are around 90%, as high as 90% of the metabolic function that is required to be human. All the chemical reactions and all that, all the production of things comes from microbial genomes rather than our own genome. And so when you think about it in that light, that these microbes that we harbor within our system are the collection of genomic material to allow us to function as humans, when we start losing big chunks of these microbes, we're losing capability, right? And when we lose capability, we lose the ability to exist in this environment in a healthy state. And we've done a great job with modern medicine of patchworking ourselves, right? Of going, okay, this disease is creating this dysfunction, we're going to patch it up, Band-Aid this, Band-Aid that, and kind of put ourselves together to remain alive for a long period of time. But we're not free of disease, right? We are inundated with disease. In the US, at least, 60% of adults have at least one chronic illness, and 50% of adults have multiple chronic illnesses, more than one, right? So it's really scary to think. I call it a mass extinction, right, of human functionality. And the analogy that I would give to people to that, for them to really appreciate it, is like, imagine if we saw a situation where the next generation of kids, because of our choices and our practices, the next generation of kids are going to be born without a spleen, right? And then their children are going to be born without a spleen and without half of the liver, right? How would we feel about the choices we're making right now? And that's exactly what's happening, because each generation is delivering to the next generation a less diverse microbiome, right? And that's just going to get worse and worse over time. So if you just look at the last few decades and the loss of species that we've had within our system, it's really quite scary. And the fact that our closest hunter-gatherer foraging ancestors have double the diversity we do.
Yeah, it is scary. Brilliant, Kiran. I'm mindful of your time, but is there anything that you would just want to conclude with or sort of re-emphasize maybe?
Yeah, I mean, I think one of the really important things that people should understand and appreciate right now is that we live in a very exciting time, right? 10 years ago, we knew a fraction of what we now know about how the human body functions. Keep in mind, going back to what I said earlier, where the vast majority of metabolic and chemical activity in our system comes from microbes, right? And we didn't start discovering this till only about 10 years ago. So in the previous 100 years of clinical and medical research, we were only looking at 10% or so of our cells, right? Until we started diving into the microbial system, did we not really understand the true root cause of many of the conditions that we suffer from. The good news about that is that many of the things that we suffer from, that we're all concerned about, whether it's metabolic, immunological, neurological, cognitive, many of those things have root causes in the microbiome, right? And it's an ecological problem in our body, which means we can change it. Right. So conditions that were seemingly incurable just a couple of years ago, like Alzheimer's or Parkinson's and lupus and things like that, are probably going to be cured by simple probiotics or prebiotics or postbiotics over the next few years, right? So we live in a very exciting time because we're finally understanding how the human body functions. There are a lot more options in managing your health than we previously knew. And I think one of the most important messages to people is that they have a lot more control over their health and their outcomes than they thought they did, right? We've developed this system where we have doctors up here in a hierarchy, and it's up to them to control our health and wellness, right? And they have very limited tool sets and limited understanding on how it all works. But what we now know is that our choices, our behaviors, and the things we choose to incorporate into our lives has a much more profound effect on our overall health and wellness than we thought. So, keep in mind that you have a lot more power to control your outcomes than you previously thought. And simple things, simple choices throughout the day will make a big difference over time. Right. So it's an exciting time. I think a lot of issues that people are dealing with that were seemingly endless, incurable in some way or the other, will have and will have very strong solutions. And a lot of it are going to be very simple things that people can do.
Yeah, I think that seems to be quite a common message that we get with our guests. This idea of small, simple steps are the way forward for most of us. Many people feel overwhelmed as it is, so we need to kind of be kind to ourselves with some of these behavioral changes. But also the fact that we can feel empowered. It's very easy to make everything sound quite doom and gloom, especially at the moment. But as you say, there's so much that we can do. There's so much that we can control. And some of the things that give us the biggest bang for our buck are actually quite subtle changes and little things that we can do in our days. So I think that's quite a powerful and empowering conclusion to today's conversation. The fact that, yes, that microbiome might be a lot less diverse than our hunter-gatherer friends, but we know ways that we can start to reverse that trend.
Absolutely. And know that there are, thousands upon thousands of brilliant scientists out there working on this stuff day in and day out, right? And when it comes to the microbiome, as an example, we've published, not me personally, I've published, I think 6 or 7 papers in the last 5-6 years, but in general, the scientific community has published over 50,000 papers in the last 5 years alone, right? So I mean, it's a mind-boggling amount of work that's going on. So and that's also super exciting because you've got so much commitment to understanding this part of ourselves, which is really the largest part of what controls our outcomes. So, so stay tuned to programs like this because, this is how you gain your information and your knowledge and empower yourself to make a change, right? So some of the things we talked about today are simple steps people can take to empower change within themselves and their family members and their kids and advocate for that. So I really appreciate you having me on because all the research we do and all the work that we know and the knowledge that we end up gaining means nothing unless we can give it to people and translate it to people so they can use it. So, these are the types of channels and resources that we need to get it to people.
Yeah, no, absolutely. No, thank you for coming on, Kiran. I really appreciate it. It's always a privilege to hear you speak around these things. So thank you very much. And I'm sure our listeners are going to really enjoy this.
It's my pleasure. Thank you.